How's it going, everybody, and welcome back to our Enterprise Lab. In this video, I'm going to go ahead and pull it up real quick. We're going to be focusing on getting the Catalyst distribution and access up and running in this video. So I'm actually going to go ahead and scoot this up just a little bit and bring this down so we have it. So I can have it up, this pulled up, and I'm going to go ahead and get out of the way. So, actually, before I do that, as we start going through these individual sections, I want to make sure that everybody understands that I'm not going to be going through in-depth explanations of how these technologies work, right? This is me trying to show you guys how to interpret the tasks and then go through and actually deploy them. So pretend like you've already done all the work for the CCA lab and it's game day. Like you're in the lab, you're in the room, you're in front of the computer, and you've already hit the let's start exam button. That at least that's what it used to be, and you're ready to go. You get your tasks pulled up and it's game on. So that's what we're going to do. Now that doesn't mean I'm not going to spend a little bit of time like how to interpret the question or interpret the task. I am going to go over that, so we'll be able to take a look at those details as we're going along. So without any further ado, let's dive into what we're going to do. So a quick cursory look at this, and this is something I actually suggest everybody does as they're diving into every section of the lab, because if you don't take a couple minutes to interpret the lab tasks and then come up with a game plan of how to handle them. So for example, it says configure VTP with domain enterprise. Access layer switches should dynamically negotiate IEEE standard trunking. Access layer switches should not be configured with the VLANs directly. Any endpoints connected to an access layer switch should be put into forwarding mode. And then it comes with the root bridges, and then secondary root bridges, and egress point for odd VLANs, egress point for even VLANs. Both switches should be backup egress points for each other. Now, based off of that output, it's straightforward what they're asking for, right? They're asking for, I wrote it, but the task is we're going to be using dynamic VLAN propagation through VLAN trunking protocol. VTP client on the access, VTP server on the distribution switches. They want we're not going to be configuring the trunks on the access switches. We're going to configure them on the distribution, and then through DTP, dynamic trunking protocol, they should automatically inherit the correct encapsulation that they should be using. The part that could be a little confusing, and I did this on purpose just to give you an example of some scenarios that you might run into in the real world, where it says the switches should be the egress point for odd VLANs and then egress point for even VLANs. Now, what this bullet point is missing is which protocol do you use, right? So the lab exam won't be that generic. It'll give you a specific detail, and then use X address for your default gateway or for your VIP. So you're not going to get one that generic. So, but you're in the CCA lab, right? This is a Cisco exam. So if you see this, what would be your first thought to use as a solution for this? If your hand just went up and said HSRP, that's what I would suspect. You're not going to throw VRRP into an exam unless it specifically says. So that's what we're going to go do. Now, we're going to do primary and backup, so we'll configure that. So we're going to be doing a full solution here as we're going through. So let's go ahead and knock this out. So on the switches here, we're going to go ahead and, so the first question is, how do you attack it? So the first, that's a great question. Where do you start? You got all these tasks. They all have to be completed. But if you don't do them in the right order, that can come back to bite you. So, where do you start? Well, the simple answer is from the top down, right? You're going to go through and you're going to configure your trunk links. You're going to configure your VTP domain and all that type of stuff. Then you're going to go down here and make sure that all that connectivity is working the way you expect it to, and the VTP has been accepted and all that type of stuff. Trunking before VTP, and then once you've created VTP, then you can create your VLANs. Do them in an order based off of the way the task is written, so that operationally, when you start adding config, it's automatically distributed, right? You don't want to configure VTP first, then VLANs, and then trunking. It's out of order, in my opinion. So come up with an order of operations that you know will work. So the first thing I'm going to go do is on switch 21, which is going to be still way over here. Thought I was far enough over. The drawback when you've got this many pieces of equipment in your lab. So switch 21, I'm going to come in here, go to global config. I'm going to type in show CDP neighbors. We're going to see switch, because we haven't configured anything, gig 10, 11, and 12. Okay, so I'm going to type in interface range is going to be gig 10 through 2. I'm going to type here switch port mode of trunk and switch port, and it tells you can't do that. Switch port trunk encapsulation .1q, switch port mode of trunk. And then we're going to go ahead and I'm going to say VTP domain is going to be enterprise. Okay, and then I'm going to go ahead and create VLAN. It's going to be VLAN 10. Name is VLAN 10. VLAN 11. Name VLAN 11. Now it doesn't say to name them, but I'm going to do it anyway, right? So do show history. I'm going to go ahead and take these few lines of config, and I'm going to dump it onto switch 2. Actually, let's do this. Onto switch 22. And I'm going to go ahead and copy pasta. There we go. Okay, so now I'm also going to have to go in on these interfaces here, gig 2 and gig 3, respectively, get them going. Because if I come over here and I do show VTP domain or status, it does say enterprise. And we can see if we were to do a do show VLAN brief, we can see that 10 and 11 are coming through. So we know the propagation worked because these guys propagated up this way. So what I'm going to do now, if I go down to 23, 24, and 25, and it says that there's an MD5 digest BTP protocol. Interesting. Okay, so I'm going to come up here and type in hostname. It's going to be switch 23. And then I'm going to do show interface trunk. We can see it negotiated it. We can see the VLANs that are allowed, which is great. Do the same thing over here. Hostname is switch 24. And then we're going to do show VTP status. Do show interface trunk. Just make sure that the negotiation protocol, the negotiation is working and you are getting VLANs. So when we get, let me wrap up switch 25. Hostname is switch 25. And do show interface trunk. Do show VTP status. Perfect. Now let me pause real quick. And so why did I verify the way that I verified? The way that I verified was knocking out 2 birds with 1 stone for the first one. Is trunking working? It is, because we can see that through the N-802.1q. And then we also can tell by this right here that the VLANs have been created and they're enabled on the trunk. That's a key capability, right? If the VLANs weren't there, that'd be a bad sign. So with that being said, that gives us capabilities that we didn't have already in play. Now I need to configure these interfaces downstream, and to get them, because what you want to do to use your time most efficiently is be specific to your configurations. So what I normally will do when we get into more involved configurations and we're not doing a couple of one-liners is I will pull up Notepad and I will start using Notepad to build a config, and then I'll just make adjustments to the config as I'm going along. So I can adjust it per device. So like when we get into BGP and MPLS and stuff like that, and it's a lot of repetitive config that's just going to be the same, or slight variations in a bulk config per device, I'm just going to use Notepad to make edits, because that's just how I do things. So, but that makes the most sense for most cases. So with that being said, do configurations where they make the most sense at the time you're doing them. So that's what we're going to end up continuing to do. So right now we've got this task done, and we've got, that's pretty much it right now. It didn't say create the VLANs, but it just said that the VLAN should not be, we needed the VLANs propagated. We can see the VLANs right here. So now what's the next step? Well, I'm going to continue going down the list of things that we need to do. So let's go ahead and down to the next step. So on 23, 24, and 25, I'm going to type in here VTP mode is going to be client. Simple as that. I'm going to copy this command out, and I'm going to paste it into 24 and 25 respectively. Just so that's a one-liner, right? There we go. Any endpoints connected to access layer switches should be put into forwarding mode. So what does that mean? It's going to be repetitive config again. It's going to be gig 02 and gig 03. So I'm going to go back over here to 23, 24, and 25, and I'm going to go into interface gig 0/2. It's going to be switch port mode of access, switch port access VLAN 10, and then spanning tree port fast. Okay, do the same thing on 3. $11. Okay, so do show history. I'm going to take these few lines of config and I'm going to paste them into 24 and 25 respectively. Just like that. So that's how you would mass configure those interfaces. So tasks 1, 2, 3, and 4 are now complete. Now it said switch 21. Let's go back over to switch 21. Switch 21 should be the root for all odd VLANs. So I'm going to type in here. So this case here is going to be spanning tree root, spanning tree VLAN 11 root, and I'm going to say primary. Now it also does say that both switches should be secondary roots for each other. So I'm going to type in spanning tree VLAN 10 root secondary. Okay. On 22, I'm going to do the exact opposite. So spanning tree VLAN 10 root primary, and spanning tree VLAN 11 root secondary. Okay, so if I do show spanning tree for VLAN 10, I'm going to see this is the root. If I do VLAN 11, this is not the root, but it gives me a pointer to where the root should be. Okay, and that's exactly what you'd expect to see. So everything's working the way you would want it to. And gig 1/0 happens to be the current root bridge for whatever. And the reason why is because these interfaces right here are not configured as trunk links. Now, the question is, in a real world design, what's the first thing you would do with these interfaces right here? Gig 2 and gig 3 on each switch? You throw them into a port channel, right? And then they'd be trunk links. But my distribution and access section says nothing about that. So the question to you is, do you configure something that is not stated to make it a best practice exam? The answer to that question is no. If the task is not specifically laid out in your task list of things to do, don't do extra config. You don't get extra credit for it. So I actually did have somebody ask me this question a long time ago. If I make a mistake in a task in a particular section, but I do extra config over here, is that going to make up the difference? And the answer is no, it's not. Cisco does not give two yahoos about you going in there and optimizing something on the device they didn't ask you to do. They're not going to test you. They're not going to check on you for that. They're not going to they're not going to look for it and say, oh, well, Jeremy did a great job and he added XYZ to the capability, and so since he was such a nice guy, we're going to go ahead and just give him credit for that. Cisco's not going to care. If you did not configure all the tasks listed in the task list, you don't get credit for it. So, with that being said, this is a great example. I actually overlooked it when I was writing the lab. It didn't even dawn on me. But in this particular case here, we're not going to be able to configure it. So, because the lab doesn't say anything about it. If the lab does not specifically state configure it, you leave it alone. Pretend like you don't see it. Pretend there are no interfaces between switch 21 and 22, even though there clearly are. That's just the name of the game. So, with that being said, let's go to the next little section here. So we've knocked out 1, 2, 3, 4, 5, 6, and 7. Now it says switch 21 should be the egress, primary egress for odd VLANs, 22 for even, and both switches should back each other up. So we're going to do gateway redundancy. So I'm going to come back over here, and what does that mean for me? Well, I got to create interface VLANs, right? So I'm going to type in interface VLAN 10. I'm going to give that a second to show up. I'm going to type an IP address here. It's going to be 10.1.10.21/24. And I'm going to no shut it. Give that a second to come online. Obviously, you can continue moving forward in your config if you'd like to, but I'm going to slow down just a little bit just so you guys can see the config. And then do, oops. That's going to give me an overlapping IP address issue. So we've got that. We're going to say no shut. Just like that. Okay, so now what I get to go do is I get to go over to 22 and do the exact same thing. So I'm going to type in interface VLAN 10, no shut. Let's just go ahead and jump that to that part of the game right away. Okay, then we'll type an IP address of 10.1.10.22/24. And then we'll go to VLAN 11, no shut, just so we can bring it up online right away. Perfect, and then we'll go up here to the IP addressing, and then we'll throw in .11. All right, so now that I've got that in play, the next stage in our configuration, if we were to do show IP interface brief, verify everything, just to make sure everything's working the way you expect it to. And then what we're going to go to is on interface VLAN 10, we're going to type in standby 10 is going to be IP of 10.1.10.1. And we're going to put in a standby 10 for even, right? Because we're on switch 21, we're not going to put any priority in here. But I'm going to come up here to interface VLAN 11. I'm going to say standby 11. This guy, but I'm typing standby 11. Priority is going to be 150. Okay? So that's how you would set that up. So now I'm going to do the exact same thing on 22. Type in interface VLAN 10. I'm going to type in standby 10. IP is going to be 10.1.10.1. And the priority is going to be 150. And then we're going to do VLAN 11. We should get a notification here in just a second for HSRP. Standby 11. Oops. Standby 11. Oh, that's what I was waiting for. Yeah, see, I wanted to. And then we're going to do standby 11 just the way it is. Okay. So what I'm going to do now is do show standby brief. Because right now it says that still trying to figure things out. Let's see what 21's got going on here. So we're the active forwarder for both. So 10. Okay, we want to be active but standby for do show run interface VLAN 11. Priority 150. 22. Okay, there we go. So this is actually wrong, right? Active is do show run interface VLAN 10. Priority 150. Did I make a mistake and put the priority 150? Okay, I didn't. So now I have to go over here and preempt. So I'm going to type in standby 10 or interface VLAN 10 standby 10 preempt. And do the same thing over here. So interface VLAN 10 standby 10 preempt. So I want 22 to become the active forwarder. There it goes. Do show standby brief. So once it figures itself out, then it should become the active forwarder. And then 21. Oh, I didn't do the do show standby brief. There we go. So active is local, and then we should be able to go over here to 22 and do the same thing again. There we go. So now it's working correctly. Now I'm also going to do interface VLAN 11. Standby 11 preempt in the event that there's a failure. So interface VLAN 11 standby 11 preempt. Okay, so that's done. So that's pretty much what we wanted to cover. So do show standby brief. Excellent. So everything's working the way we want it to. So now that we have that in play and everything's looking good, what do we do now? Well, theoretically speaking, this section would be done. So we'd be able to move on to the next section. As long as all the check boxes, you can put a check mark next to each one of these, you should be good. Now, how do you know if you're right or not? That's where all the practice up to this point has come into play. So you should know how to do every one of the bullet items here. Configure VTP, trunking, spanning tree. You should be able to set the root bridges where they need to be set. You should be able to do primary and secondary egress points, backup egress points, secondary root bridges. All of that stuff should be really, those are all CCNA level topics. So at this point in your career, in your learning process, you should be really strong in these technologies, where doing layer 2 should be a piece of cake for you. It should even be like a non-factor. You should just be able to bang it out. So I get asked often, well, how do you remember all that stuff that you learned back in CCNA today? Well, it's repetition, over and over and over again to the point where I don't forget it. Like, I just know what it is. You learn it so well to where it's second nature, to where if you notice when I cover, if I do like any CCNA level training, I spend very little bit of time on spanning tree because I get no satisfaction out of configuring spanning tree. Because really it's already working. All you're doing is tweaking it to make it do what you want it to do. That's really the only difference. I understand root bridges, I understand secondaries, that type of stuff, root ports and uplinks and all that type of stuff. It's native understanding now. That's how it should be for you as well. So, with that being said, now, are we going to test? Well, here's where this would come into play. I can go onto these devices, and because we're at this point, I'm going to go ahead and do the config, just because I'm right here. I'm going to go ahead and pause. Actually, I'll go ahead and scoot all the way to the right here, and I'll grab those devices and get them squared away so we can start working with it. So we're looking at PC66. I'm going to go in here. This is just a router. So host name is going to be PC66. And I'm going to type in no IP routing. And this is going to be a even numbered PC, so it's going to be in the even VLAN. Odd numbered PCs are going to be in the odd VLAN. So I'm going to type in IP default gateway is going to be 10.1.10.1, and then interface gig 0/0. We're going to go ahead and do an IP address here of 10.1.10.66/24. Actually, let me go ahead and get out of the way so you guys can see the full screen on this. .0, and that's pretty much it. So I'm going to go ahead and no shut that. Give that a couple seconds to come online, and then we'll be able to move on to our next thing. I'm going to go ahead and save that config. And I'll do the same thing. And if at any point in time, if you're curious where the configs are going to be, they'll be in a in the Google Drive link that you'll find in the description. You'll be able to click on that and then go to the individual section and to the individual device. They'll all be organized that way. Okay, so that's done. So now I'm going to go do ping 10.1.10.1. Can I ping it? I can. Do show ARP. And you can see that I've got a HSRP MAC address showing up, which is exactly what you want to see. Okay, next one up is 67. So I'm going to actually grab these few lines of config right here. And I'm gonna give you guys a little cheat sheet. I'm gonna open up Notepad. Like I said, any repetitive config you can quickly make modifications to as we're going along. So I'm gonna go ahead and actually no IP routing. Pull this one out. IP default gateway. We're basically turning this router into an end host. And then we're going to go, actually pull that out, and we're going to do a do write. Okay, so now I'm going to go ahead and pull this out and do that. So now I get to go PC67, 11, and then we're going to do 11, 67. And I realized the mistake, the error of my way. I'm going to go ahead and grab all that, jump onto PC 67, copy pasta. And then 68, 10, this will be 68.10. Same thing with that, 68, copy pasta. And then 69, 11, 69. As you can see, if you do it this way here, it's going to speed your configuration process up dramatically. 70. Just like that. 2 more to go, and we'll be actually, yeah, we'll be done at at 71. So basically, this one here is at the end of the road for us, because then we have to go through and do the nexus distribution. So I'm gonna type in. I didn't have 71 prepped yet. That's my fault. 71, 11. Copy pasta. Okay. Now that that's all there. If I was to go to, say, switch 21, for example, and if I do a show IP interface brief and start pinging 10.1.10.68, there it goes. Then we'll do 70. And if I do a show ARP, I can see stuff showing up in my ARP table, which is awesome to see. And then switch 22, same thing. If I do a ping 10.1.11.69, there it goes, and then 71, just like that. Did I forget to no shut the interface? Yep, I bet you I forgot to no shut the interface. Either that or there's a problem. Do show IP interface brief. Do ping 10.1.11.1. Oh, you know what? PC 71 looks weird, so I think I might just have to bounce the device and bring it back online. But I'll come back to that at a later point in time. But at this point in time, as you can see, we have connectivity up and running. So that I don't know how involved your layer 2 section is going to be in the lab exam, and it really doesn't matter, right? As long as you have put in the required amount of training and preparation that you need to, and you really never know, right? Sometimes I know CCA lab exams are expensive, but sometimes you have to just take a chance on the test to see what it is, and that's what I did in my first attempt. I just wanted to go see what the lab looked like. I had no expectations of passing. I wanted to pass, right? But I had no expectations of passing because I didn't know how much more preparation I needed to go through, and I needed a lot more preparation. But it was a learning experience for me. I was like, oh wow, I am in over my head. But at the end of the day, if you were to put me back in time right now with what I know today versus what I know back then, I feel like I'm much stronger of an engineer now than I was back then, because I've got more than a decade in the field. So, not to say that I wouldn't get hung up on some things. I had to think about it, because the beauty of my job today is I focus more on, I have the time to look at it versus trying to come up with solutions on the fly. So, you handle them as they come. But that being said, ladies and gentlemen, that is pretty much it for this video. If you have any questions, please leave a comment in the comment section below, and I'll get back to you as soon as I can. Remember that in the description, there will be a link to all the information you need for this to work. Until next time, guys, thanks so much, and I'll see you guys in the next video.